Hello there and welcome to the Materials and Textures lecture. In this lab, we are going to look at the following three areas: meshes, textures, and shaders, which are all very important components in the Unity platform. So let's start off by looking at meshes. If you're working in a two-dimensional game, graphics will normally consist of flat images called sprites, such as the ones that you see here or the ones that you see here. And to animate these sprites, all we do is we keep in memory a sequence of sprites and we change and flip them in sequence. So if, for example, we wanted to show a character running, we would change the location and the appearance of this sprite in a specific sequence on the screen. And if this is done quickly enough, the player or the user gets an impression that the character is moving across the screen. So all the possible positions of the sprite is basically created and then it's animated in a quick sequence to give an impression of movement of the character. Okay? That's what we do in two-dimensional space. In three-dimensional space, it's a bit more complicated because we need to work with the concept of depth. You have three dimensions, x, y, and z axis, and the z axis essentially represents depth. So to represent 3D objects, the way that computers work is to process them as a collection of points, or what we call vertices. Okay. Now the key principle here is that the fewer vertices an object has, the faster it can be drawn. Because in very complicated game scenarios, there's actually a lot of objects that need to be drawn. And so you want to maximize the speed at which they're drawn and also optimize the number of or the amount of memory that an object occupies when it's stored in the memory of your graphics card or in the main memory of your computer. So to do this, we try to minimize the number of vertices or points that are used to represent an object. And with respect to these, triangles have two very important properties. Because with one single triangle, you only need one more vertex to make another triangle. So if you think about it, a triangle has got 3 points, and if you create one more point outside of that triangle and you connect the original triangle to that single point that's outside the triangle, you automatically make another triangle. So you only need one more vertex or point to make another triangle, and therefore using strips of triangle, you can model any 3D object to any level of complexity. So meshes are basically a series of interconnected triangles that form objects, and they provide 3D definitions of a model, and they can be processed very quickly. So here's an example of a mesh. You can see here it's very clear. In this particular situation here, the mesh of the model of the dog object, the mesh here is more complicated, and there's also a texture applied to it as well. But you can see it's also basically a series of interconnected triangles. So the mesh contains all the vertex information that defines the 3D shape, and in addition to that, a model we can define a model as an object that has a mesh that will define all its dimensions, but the model will also contain other things such as textures, materials, shaders, and other meshes as well within it. So we'll see later on what we mean by materials, shaders, and textures. So let's take a look at an example of meshes used in a particular object. So let's go back to Unity. So let's start up a new Unity project, okay, in any particular folder that you're doing your tests in. And let's create now a folder called models in my assets pane in my project view. So let's say create folder, and I'm going to call this models, sorry, M-O-D-E-L, models. And what I'm going to do now is I'm going to open this, and I'm now going to import a FBX file. So later on we'll see what an FBX file is, but this FBX file is basically representing a game object that's been created on the concept of meshes. It's basically a torus. So we're going to first quickly open this up, and you should be able to see in the folder containing that's holding this video, there should be another folder called our tree. Let's open that up, and you can see something there called torus.fbx. So what we can do, there are two options here. in order to actually import this torus, torus model into Unity. You can just drag and drop directly from the folder, which is what I'm going to do now. I can just drag and drop and it appears here, as you can see. And the alternative is, I'm going to delete it first for now. I'm just going to delete this. The alternative is to go to Assets, okay, then click on Assets, click on Import New Asset, okay, then you go to the particular folder, in this case our tree, and then you click on this FBX file, torus.fbx. Okay, so there are several ways that you can import a model that's developed in some particular application package that has been imported in some particular file format, in this case the FBX file format. Okay, so now let's drag this torus icon into the hierarchy view, and you can see the torus appearing there, or at least the local coordinate system for the torus appearing. So let's zoom in a bit to the torus. We click on the torus. Let's zoom in a bit so we can see where the torus is. Oops. Yep. Okay. So now you can see, zoomed in a bit too far. Let's try and increase the size of the torus. We can increase the scaling of the torus that we have just imported. If we click on torus, you see the scale factor is 0.01. By default, when Unity imports all the meshes, any object with meshes, it's automatically scaled down. Okay, so let's change the scale factor. We click on the torus icon in the models folder in your assets pane. You get this appearing in your inspector scene view, and if you change the scale factor value from 0.01 down to 1, it will increase the size. So you're saying that you want, by changing it to 1, you're telling Unity to allow the model to enter the scene as in exactly the same size as it was created. So you change the scale factor to 1, you click on the apply button. Okay, so now it's zoomed up a bit. Okay, so it won't be so small. So now we go back to the torus. As you can see, the torus is composed of a series of interconnected meshes. And the local coordinate system for the torus is located directly in the center of the torus. And as we saw before, we can move it. If we click on this axis, we can move it up and down. If we click on this axis, we can move it front and back. And we click on this axis, we can move it left and right. So this is the local coordinate system for the torus, and the torus is composed of a bunch of meshes. And if we go over to the inspector view, if we turn off the mesh renderer, if you look at the inspector view here, and we look at the mesh renderer component, if I uncheck this checkbox for the mesh renderer, you'll see that the torus basically disappears from view. So without a mesh, this torus object actually has no shape. The shape of the torus object is given by the mesh. So let's turn that back on again. Okay. Now, in addition to this, in addition to the models that we have created here, this is basically from a folder that was previously linked with a textbook that I'm currently using for this course. And so this FBX file for the torus is created using some kind of application program, for example, Autodesk. But I can also import models from the Unity online store. So to do this, again, you have to make sure that you have got a proper broadband connection. So I click on all models, and then I click on asset store here, okay, and then a whole bunch of, oh, it's not good. Let's try that again. All prefabs. Let's click on the asset store again. It's not working. Let me try again. Asset store. Okay, now the asset store is working. Let's go to models. Okay, so as you can see, sometimes the asset store works and sometimes it doesn't. Again, depends on your broadband connection and also whether the server is being heavily loaded on the Unity at the Unity end, the Unity server. Okay, so so be patient. If you're working at home and sometimes you can't connect, then just try again at different times of the day, because the Unity server may be very heavily overloaded at certain times of the day. Now let's look for a particular model called Robot Kyle, R-O-B-O-T-K-Y-L-E. So now I'm going to search for that. And now you can see I'm finding this robot here. So I found the robot Kyle, R-O-B-O-T-K-Y-L-E. Okay. So the asset store is robotcarl.fbx. The format is the fbx file format. I click on open asset store. Okay, again, you need to do this in a place where you're not behind a firewall or proxy server, because that tends to interrupt settings. And you open up the asset store. Once you open up the asset store, you click on import. Okay, you click on import, and then it opens up the package, which you should see here, and then you then click on the import button again, and then it compiles the scripts, and then it transfers all the particular textures, shadings, FBX files, and so on from the Unity Asset Store, the Unity Online Asset Store, to your folder of this project. So you can remove this now once you've imported it. You can just close the window. So now you can see in your assets pane, we've got a new folder called GMO Assets, and this represents the robot Carl that we've just imported. So if you are not able to import this because you are currently behind a firewall or proxy, or you don't have a good broadband connection, you can inside this lecture folder, I've also included another folder containing a project that contains this pre-imported asset. So you can open that project in case you didn't manage to download the assets from the Unity Online Store. So if that's the case for you, just click on File, Open Project, Open Other. If you go to Test2, okay? So Test2 in your material texture folder should basically contain a project that already has this imported robot asset, just in case you are not able to open it the way I did if you are behind a firewall or you don't have a good broadband connection. So I'm just going to reopen that. Okay, so you should see I've got the GMO assets here. Now let's just see how this works. If you open up this and you look in assets and you look in robot Carl, you see something there called robot Carl, and you can drag this onto the scene, and that's your robot Carl for you. So if I zoom in a bit, oops, okay, zoom into robot Carl here. Okay, so you can see robot Carl. I can drag and move robot Carl around. So again, if you look carefully at robot Carl, you'll see that, let me just change the size of this pane here, this view here. Okay, we see robot Carl here. You see his body is composed of a whole bunch of meshes as well. Now let's see a quick demo involving a robot Carl. Now if I click on the demo folder, there's this kind of square thing here. Can you see this MC demo? So this is a scene, and like I have said in a previous chapter, a scene is equivalent to a level in a game. So here what the people who have worked on this asset have done is they created a scene which contains several models of this robot to demonstrate how textures and shaders and materials can work on this particular robot. So let's take a look at the scene. Now if I try to open this scene, Unity will ask me whether I want to save the current scene. So this is a current scene. If I want to save the current scene, I will say File, Save Scene As, and I might say like, okay, I might say Scene 1. I can save this as Scene 1, so I save this scene first. So once I've saved this scene, I can open a new scene. I double click on MC Demo, and so now I've opened a new scene. So now in this scene here, so this is the new scene here, as you can see. And in this scene here, I already have a particular script. So this scene is actually prepared by someone else already. As you can see, the scene shows a bunch of robots. There's actually some positional lighting here, and there's a whole bunch of objects in the hierarchy view. So this scene is already prepared by the person who created this robot Carl model, and this scene is basically used to demo the various textures available. So now to see how this scene works, we just click on the play button, and remember, if I click on maximize on play here, I click on maximize on play, I should be able to see this scene in full view once I start playing the game. Okay, so I click on play here. Oops, the robots have gone off. I think that's because I dragged the camera to a wrong position. So never mind. If you click here, for example, shader, you can see the robot here is changing color. Okay, so here this particular game is just to demonstrate the results of what's happening. Let me just switch the camera back so that I'm going to move the position of the camera here. So I'm going to move, I'm going to click on here, I'm going to click on the camera, I'm going to move it back so that I can see these things better. Let me see, okay, move it here, I'll move it in a bit, okay, let me move the camera back a bit, okay, let me play this again. Okay, maybe it's not so good. Wait, let me just drag the camera down if I can. If I can just drag the camera down. Ah, great. So now I drag the camera down. I go back to play again. Okay, so now everything. So now, for example, when I click on this shader, you can see that this robot is changing. When I click on this shader, again, you can see this robot is changing. So this scene is to demonstrate the results of different shaders and textures on the robot. We're going to talk a bit later more about shaders and textures in the remaining part of this lecture. So just play around if you want to. Okay, so that's importing a asset from the Unity online store. Now let's go back again to our lecture. So we talked about meshes, we talked about importing models from the Unity asset store. Now keep in mind that all the models I've imported just now, or I worked with just now, are free models. Okay, that means people just upload to people who create them, graphic artists who create these models, upload them for free onto the asset store. You can think of it like open source graphic components. It's for free, anybody can use it. There are also paid components which you can see in this model here. So there are some people who are full-time graphic artists. They will also upload assets into the online Unity online asset store for other people to use, and of course they may charge a small fee for this. So it's pretty much like you know, downloading apps from the Apple App Store or from Google Play and so on. Okay, let's look at textures. In Unity, a model consists of textures, shaders, and materials. So the way it works is you are going to create a texture, and then you're going to create a shader, and you combine them together in something called a material, and then you apply the material to the model. And that's how you give appearance, a 3D appearance to a game object in Unity. Okay, that's the basic format of basic structure. Now, textures are basically flat images that are wrapped around a three-dimensional object. Sometimes textures get applied incorrectly because the model has no idea what is the correct way to apply texture. Later on, we're going to see a demo of how we apply texture. But keep in mind that because textures are not necessarily always fixed properly, when you apply them into a material and then apply them to the object, the texture may look very funny. It may look a bit warped and out of shape. So in that case, we have to use something called an unwrapped texture. So an unwrap is a map that shows exactly how a flat texture, you can think of a texture as a piece of cloth that you're going to wrap around a three-dimensional model. So for very intricate models, just like the robot car there that we saw earlier just now, it's important to be able to generate an unwrap. So we're going to take a look back again at an unwrap, but let's go on to see first what is a shader, and then we'll demonstrate that in collaboration with a texture. Now, shader basically determines what kind of textures can be applied on a material and how this texture looks like when it is applied. Okay, so let's take a quick look at a shader. Let me go back to Unity again, sorry. So let's take a quick look at shader. Let me save this. So let me save this scene. I'll save this scene as scene 2. Okay, let me create a new scene now so that we have something to play with. So now a new scene. And let's just close everything. So let me just create a material here. So now I'm in the asset pane of the project scene view. I'm going to create a material, and let's call this material 1. So when you create a material, there is basically a shader associated with it, and you can see that if you go in the inspector view and you click on the shader drop down box, you can see a whole bunch of values available. And if you choose any one of these values, you can see it changes the way that the lighting reflects off the surface of the material. So if I click bump diffuse, it looks like this. If I click bump specular, see it looks more shiny. Okay, can you see that? Bump specular versus bump diffuse. So you can just work around with all the different types of shading that's possible. You can see there are actually so many different types of shading which reflects the quality of the 3D rendering engine that you have in Unity, which can reflect the myriad possibilities of light reflecting off a surface of an object. So that's accomplished using the shader. Okay, let me go back here. So the shader, as I said, determines what kind of textures. Some kinds of textures can be applied with some kinds of shaders, and some kinds of textures cannot be applied with other kinds of textures. So it determines what kind of textures you can use and how this texture, most importantly, how this texture looks like when you apply it, okay, to an object. So this is some explanation. As we saw, the main types of shaders: diffuse, specular, and bump. Diffuse is like the lighting is evenly distributed. Specular makes the object look shiny. Bump makes the object look like it's got a very bumpy look, so it looks more physical and more 3D. Okay. Then the main color determines the color of the ambient light shining on the object. Specular color, shininess determines how shiny it is. The texture tells you what texture to put in a shader, and so on. Okay. The tiling defines how often a texture can repeat on a model. It can repeat in both the X and Y axis. We're going to see a bit more of this later on. So that's a shader. And now let's take a look again at how we can apply a shader. So let's create a texture. Let's import a texture first. So we will create a textures folder. Let's create a textures folder. And let's also create a materials folder. Okay, M-A-T-R-A-L-S. So again, if you recall from my earlier chapter, we said that it's always good to create folders to hold the main kinds of assets you're going to have, which are materials, models, prefabs, and scripts. So when you organize them this way, it's more easier for you to work with them. So we've created a materials folder, a textures folder. Let's drag this material one that I've just created in the materials folder and the textures. Now let's open the textures folder. Now let's bring in another texture. Now let's go back to our tree. We have two possible textures here in the our tree folder. I'm going to drag both of these textures into the project view, into the assets pane in my project view. Okay, so I've imported these two textures. Then let's add a cube to the scene now. I'm going to go to my hierarchy view. I'm going to put a cube. I'm going to scale this cube up a bit. I want to make it look like a wall. So I'm going to scale it. I'm going to click on the scale button here. Okay, click scale. So I'm going to make it maybe a bit more narrow here. And then I'm going to scale it up here a bit. And I'm going to drag it up a bit. So you can do it any way you want. Okay, just try to scale the cube so that it looks a bit like a wall. And now what we want to do is we want to put the texture that we have just imported onto the material that we have created. So let's go to the material first. So this is the material. Now you notice that the main color that is for material 1, let's put let's leave the shader as bump diffuse. Now if you look at material 1, there is a small box here that says none texture and select. Okay, so what we are going to do now is we are going to get one of the textures that we've just imported. So, and I'm going to put this and apply this to this material. So I'm going to take the texture, apply it to the material. So we go to the textures. We can choose either one of these textures. So let's choose the bricks texture. Oops, sorry, I highlighted it. Sorry. So let's go back again to the materials. We try not to highlight it. Okay, material. So keep the info for the material displayed in the inspector scene and go to textures. Now I'm going to drag the brick texture all over to here. I'm going to pop it in there. So now you see a material 1. Now you can see how the texture looks. This is a preview of how the texture. So the texture, you can think of it as a graphic, as a piece of cloth, and you're wrapping it around an object. Okay. Here the preview is an object in a sphere. So now I'm going to take this material that I have, material 1, and now I'm going to drag it. Okay, I'm going to drag it and put it into the cube. Okay, once I release the button, you can see the texture is now applied to the cube. So it looks a bit like a wall. Now, I can change how the texture is being is being, how to say, I can change how the texture is being kind of wrapped around the object, around this cube, by using the tiling. Okay, so here we see the tiling is actually showing the frequency or the interspacing between the individual components of the texture. So if I change the tiling for X, now keep a close look on the scene view. Now if I change from 1 to 2, okay, see how it looks like now from 2 to 3. See how it looks like from 3 to 4. So you see the distance between the bricks actually becomes smaller and smaller. Now, same thing for the Y. Let's change the tiling back to 1 for X. Okay, and then we change the tiling back to Y for 1. Again, we can change this from 1 to 2 to 3 to 4 and so on. Again, you see the distance between the bricks on the Y-axis changes as well. So we can change this if we wish to. Okay. Now let's before we end, let's just put a small directional light into the scene. Let's play around a bit. I'm going to add a light into the scene here. Create. I'm going to put a directional light. I'm going to store this light at a slightly different value here. I'm going to put the light, okay, at position, the X position. I'm going to put it at 0, and the Y position I'm going to put it at 10. And the Z position, I'm going to put it at -10. Okay. And I'm going to give it a rotation of 30, 0, 0. Okay. So that's my light. Okay. So now, with the lighting, when the light comes on, automatically, let's look at the directional light. When the lighting comes on, automatically you see the lighting here changes. Now, as I told you before, this button here that you see on the top, it turns on the what we call the ambient lighting in Unity. So in Unity, there is by default ambient lighting that's turned on. You can think of ambient lighting like there's a large, big fluorescent lamp right at the top of the scene and it's shining down on everything in a uniform manner. So if you don't have any kind of lighting objects in your scene, by default, the ambient lighting is on. The moment you create a light source in the scene, such as a directional light, the ambient lighting will automatically be turned off. Okay, let's see where the position of this directional light is. So I double click on directional light, you can see this is where the directional light is shining in like this. Okay, so this is a bit far away from the camera. So let me try and move the camera a bit closer in. I'm going to move the camera a bit closer in here. Sorry, I'm not going to scale the camera. I'm going to move the camera. I'm going to move the camera a bit closer in. Okay, so that you can see properly. Okay. The camera. Just so I can see the wall properly. Okay, so now I'm going to move back to the wall. I'm going to double click on the cube. So just again to notice, this is the directional light is shining in. So I'm going to click on the cube so that I can zoom in. Oops, let me just figure out where the cube is. Cube. Oh, okay. So this is where the cube is now currently, as you can see, and there's a directional light. Now, if I turn off the directional light, so if I now click on directional light and I uncheck the directional light in the inspector view, the directional light disappears and the whole scene is in darkness now. The whole scene is in darkness because ambient lighting is turned off. The ambient lighting was turned off because I introduced a directional light into the scene. So automatically Unity turns off the ambient lighting to be able to show you the effects of the directional light. So if I turn off the directional light, everything goes into darkness. If I turn it on, then the specific, I turn it on by clicking on the checkbox button for the directional light in the inspector view. It comes on again, so you can see that the wall is lit according to where the directional light is located at. Okay, and if you want to see this more clearly, we can rotate around the view. So again, we saw before, we press the alternate key, you can rotate around here and see how the wall looks like. So with the directional lighting, okay. Okay, and if I turn on my directional light, then I have to make sure I turn on my ambient lighting. So if I turn on the directional light and no longer want to use the directional light, I have to make sure I turn on my ambient lighting. I go on to the ambient lighting button here in the scene view, and then click that, and ambient lighting comes on. Okay. So to summarize, we have looked at meshes, textures, and shaders, and how they are applied to the various game objects in Unity. And that brings us to the end of this lecture.